Let's start with the basics of electricity. First, we will go through different components and their symbols. We will understand what's current, what's voltage or potential difference. We will see how we can branch components in series and in parallel, and how will this affect the current and the potential difference of the circuit. This is the simplest diagram any scientist can create. It's made out of a battery, a switch, and a bulb. And this is how the diagram is represented. We don't draw the components. Instead, we replace them by the symbol components. These are the common symbols that you need to be familiar with. We will go through as many as possible during the lessons. Okay, so let's first understand what is the current. So we all know that inside a copper wire, which is a conductor, we have atoms that have free electrons. And these free electrons are free to move inside the copper wire, but they don't have a specific pattern to move through. They just drift randomly inside the copper wire. All right. So in order to make or create a pattern or a sort of a flow, we will apply what we call a potential difference. So by having a negative sign on one terminal of the copper wire and a positive sign on the other terminal, we can then force the electrons to move from the negative one to the positive terminal, creating a sort of flow, which we call the electron flow. This is how we create a current inside a copper wire. So, in fact, before the 17th century, scientists agreed to think that the current is actually flowing from the positive to the negative, which means that they thought that the positive protons, positive charge, are the one that can move toward the negative. And so they have made all the rules for electricity and circuits based on this mistake, if you want. But then after that, after the 17th century, it was discovered that it was actually the electrons that can move and not protons. Protons are fixed and stuck inside the nucleus. And it's the electrons that are orbiting around and they are free to move. But since this discovery was made, as I said, after almost all the laws of electricity were stated, it was really, really hard to change everything. So they agreed to keep the current flowing, calling it the conventional current, from positive to negative. So here, this arrow represents the conventional current, and that's the actual electron flow. In the questions, we will use the conventional current. All right, now let's see how we can measure the current. The current is, as a definition, it is the rate in seconds of charge flow in Coulomb past a given point in electric circuit. So just like we're familiar with the idea that if we want to measure a wave frequency, we would count how many waves, crest and trough, are going each second. In this case, in electricity, we measure the current as the flow of electric charge, the electrons, each second. It's the rate. So if we want to count here how many electrons are flowing, we would count around 21 electrons going each second through the section of the wire. But in fact, there are much more than just 21 electrons flowing in the copper wire. We have up to 6 million electrons that are flowing each second. So instead of writing this really large number, we represent this number by the Coulomb. Just like the mole, we have 1 Coulomb is equals to 6 million electrons. And so measuring how many Coulomb are going each second is the amps. So if we have 1 Coulomb that is going each second, it means that the current that we created is equal to 1 ampere. So what is Coulomb? If you're still confused about this number, think about pair. When I say a pair of socks or a pair of pens, you would go and get 2 pens. If I say a dozen of donuts, you'd go and get 12 donuts. So Coulomb is just a number that represents a really large amount of electrons that are flowing at once inside the copper wire. It's 6.24 10 to the power of 18. So how can we calculate the current? We calculate the current just like the definition. It's the number of charge that are going, which is in Coulomb, each second, which is the time in seconds. You can pause the video and solve the question. Okay, so how can we measure the current? Using which device? It's using an ammeter. An ammeter has a symbol A, and it is usually branched in series. We will get to understand the branches in the following parts of our presentation. Now, voltage. What is the voltage or the potential difference of a circuit? So in order to understand what is voltage, let's think about our bag of Coulomb. We know that this bag of Coulomb will go all the way through the copper wire and will feed the component, which is the bulb, to make it bright. But when the bag will reach the battery, the terminal of the battery, it needs a push in order to move around and complete another loop. Every time the bag of Coulomb reaches the battery, it needs another push in order to be able to complete the loop over and over and over again. So it's as if there's someone inside the battery that is pushing the bag outward every time, making a work, giving it energy in order to provide the bulb with the needed energy. Let's say that we pushed our bag with 2 joules of energy, then we can count 2 joules per bag, which is 2 joules per 1 coulomb, which means that instead of joules per coulomb, we can say this is a 2 volts. So the battery is providing a 2 volts in order for the current to flow. So it means that if our push was 4 joules, then we would have 4 joules per bag or per coulomb, which means that our voltage is greater, it's 4 volts. If you push it with, I don't know, 10 joules, then it's 10 joules per coulomb or per bag, it means it's 10 volts. So it's actually about the pushing force, the voltage that is provided per coulomb. So in order to calculate it, we can use the formula energy divided by the charge, where energy is in joules, charge is in coulombs, and the voltage has, sorry, that's a mistake. It's in volts. All right, and that's the triangle, that's the formula. And you can pause the video and try to solve this question. So how can we measure the voltage? Voltage is measured using a voltmeter, which is usually branched in parallel. We will also get to understand what does branching components in a circuit mean. Now, voltage is also called the potential difference. Let's imagine that this bag of Coulomb is being carried away from the battery, so it will leave the battery with full energy, full bag. And then once this man carrying the bag will reach the battery, the man will give out the energy that he's carrying on his back, which means that he's giving out the energies, leaving them with less energy than before. And so if you think about it, if we branch the voltmeter before, the voltmeter will give us a very large reading in volts. But if this voltmeter was branched after, it will give us a different, smaller reading in volts. So how can we then measure how much energy, how much volts does he need? And this is what we call the potential difference, because there is a difference before and after. And so we should branch a voltmeter in parallel, which means that one born is before and one born is after, and the reading on the voltmeter will give us the potential difference of the bulb in volts. All right, we can wrap it up by this analogy. Let's consider that our electrons are like a reservoir that is filled with water particles that are randomly flowing and sliding past each other inside the reservoir. When you will create a sort of a hole inside the reservoir, you're pushing the water particle downwards. You're creating sort of voltage. And now the water particle will start to flow, forcibly flow through the pipe. And they will continue flowing, and that's what the current is. And so if I want to place my ammeter in order to measure how much water particles are flowing each second in a specific position of the pipe, I can branch it anywhere and it will still give me the same exact reading. That's because it's one path, it's one pipe. But in order to measure the potential difference of the reservoir or of the battery, we need to branch it in parallel. That's because we want to measure how much it has before and compared to after, to get the PD, or what we call the potential difference in volts. And A, don't forget, it measures the current, I, in amps. Series and parallel now. Let's think of the reservoir. If we connect more than one pipe to the same reservoir, then we're creating more than one branch. It's a parallel circuit, If we have only one branch, one pipe for the electrons or the water particle to flow, that's called a series circuit. So a parallel circuit has more than one branch. A series circuit has only one branch, one path for the current to flow. Here we have more than one path for the current to flow. So in order to get the series, think about it this way. It's the same bag of Coulomb that is going to flow all around the circuit. And so if I want to measure the current anywhere on my circuit, it will still give me the same reading. And this is why we say that I for series is the same. For the voltage, it's as if one man is leaving the battery and will pass through the first bulb, giving out some of his energy, and now he has less energy in his bag. And then he'll cross again through the second bulb and will have even less. And then we'll cross through the third bulb and will have even less and less. And this is how he will return back to the battery with an empty bag, leaving the battery with a full bag. So how can I get the voltage in a series? The voltage in a series is the sum of all the voltage in the component. So how can I get the voltage in a series circuit? A voltage is the sum of all the volts of the component of the circuit. For parallel, it's the opposite thing. So in a parallel circuit, in order to get the current, it's as if this bag of Coulomb will start flowing. And the moment it will reach this node, some of the marble will flow through this and the other will continue. Then through the second one, some will flow through this branch and the others will continue. But at some point, they will all meet again and return back to the bulb, to the battery. And so we say that I for parallel is the sum of the current flowing through each branch. As for the voltage in parallel, it's always going to be the same. That's because each man is sent to a different branch. If we have two branches, then we will have two carriers of energy. If we have three branches, we will have three carriers of energy. And each man is carrying the same amount of energy, providing the branch with the same amount of energy. And so if my battery is, let's say, it consists of 6 volts, then each bulb will get 6 volts as well. That's because each man is carrying 6 volts and can provide the battery with the same amount. And so we say that V in parallel is the same. And that's the rule. For parallel, we say I is the sum, V is the same. For series, we say I is the same and V is the sum. All right, let's take this example, this application. Here we have a series circuit that the battery is providing a volts of 6 volts and the current flowing is 2 amps. So starting from the easy one in series, which is I is the same, we can say that anywhere the ammeter is placed, it's still going to give you the same reading, which is 2 amps. As for the volts, we know that in series, volts is the sum. So if my source is providing me with 6 volts, they will evenly be divided between the bulbs, considering that the bulbs are identical. So if we have 6 volts for the source, then each bulb will get 3 volts and 3 volts. But for diagram 2, we know that volts is now the same. So if my battery is providing me with 6 volts, then each bulb will get the same amount of voltage, which is 6 volts and 6 volts. All right, what about the current? The current is the sum. So if 2 amps are flowing in my main wire, then at this point, 1 amps will flow through the first branch and 1 amps will flow through the second one. And they will keep on flowing inside the wire until they will meet again at this point and will return back and they will merge again, add up to get 2 amps. All right, that's another example. Pause the video, try to solve it by your own self. That's a series circuit. So in series, we know 2 things. We know that I is the same and V is the sum. So if my source of battery is of 6 volts, then each bulb will get evenly amount of voltage, which is 3 volts and 3 volts. And since I is the same, so if my current flowing at this point is 4 amps, then at any point in my circuit, it will still be 4 amps. While for parallel, I know two rules. I know that I is the sum and V is the same. So if my bulb is taking 6 volts, it means that the voltage originally is of the battery is also 6 volts, and the other bulb will also get 6 volts. That's because V is the same. But what about the current? The current is the sum. So if we have 4 amps flowing through the main branch, then 2 amps will flow through the first one, 2 amps will flow through the second one, and at some point they will add up and they will return back to the battery as 4 amps. And that's it.